So now we're starting our Unit 5, which is the AP curriculum Unit 4. So the learning is actually going to start with 4, even though it's our Unit 5. All right, and Unit 5 is all about what can we do with derivatives. All right, so the first thing to remember is we're going to kind of go back to the basics of what a derivative is, since we spent so much time just taking them. We haven't talked about what they are for a while. All right, so the important thing to remember with the derivative is kind of two different things that the derivative represents. First of all, it's the slope of the tangent line. All right, so if we're trying to find the equation of a tangent line or something, we'll find the derivative, and that'll give us the slope of that line. And that's kind of helpful in a general, like, mathy sense when you're trying to find this stuff with an equation. But in the real world scenarios, and we're trying to use some application of derivatives, it's also important to remember it's the instantaneous rate of change. So how is my function changing at that exact moment in time? All right, so these two things represent the same thing. All right, but again, the slope of the tangent line is kind of more the mathy thing. You're just finding this line tangent to your graph. But the instantaneous rate of change, that's a really important application thing. What's happening right now at this instant, depending on what my function represents. And since the derivative represents the slope of a line, right, the units are going to come from the fact that it's a slope. So how do we do slope? Slope is the change in y over the change in x. And since our derivative is a slope, our derivative will be y values over the x values. So basically, if we know what our input variable is, all right, that's going to go on the bottom of our units. And whatever our output variable is, that's going to go on the top of our units. All right, so if you just basically remember that slope is y values on the top and x values on the bottom, that can help you figure out your units for what a derivative represents. All right, so let's say we have this function, s of d gives the hours of sunlight d days after the summer solstice. So it's important to remember just from this first sentence, all right, the d is in the parentheses, so this is my input, and that's represented by days. All right, so days is the things I'm putting into my function, which in general represents kind of our x values. All right, so the days are our input, our x values, and what does our function give out? It gives out the hours of sunlight, so that would be kind of like our y values. All right, so our input is the number of days, and our output is the hours of sunlight. All right, so what are going to be the units of our derivative of this function? Well, our derivative is the slope, which again is the change in y over the change in x. So our units are going to be the y units on top, which is hours of sunlight. And on the bottom is going to be our input unit, which are days. And generally, when we're saying this, when there's that division, we use the word per, right, for our division symbol. So this would be hours of sunlight per day would be the units for our derivatives. I mean, just taking our output unit, dividing it by our input unit. All right, for the second derivative, remember that's just the derivative of the derivative. So for our derivative, the output unit is that, so that's going to go on the top. Because that's what I get out of my derivative. That's basically the question we just answered. And we divide by the input unit. Well, the input unit is still that d, so day, or days. And if you simplify this fraction, the two denominators basically end up combining, and you get hours over day squared. So this will happen a lot, where the first derivative is just like something per something, so hours per day. And the second derivative will be the same thing, but with the bottom being squared. So here we have hours per day squared. But it's the exact same process. This came from the output of the derivative, and this came from the input of the derivative, because we're taking the derivative of the derivative to get our final answer there. But again, just keeping track of what's your input and what's your output will give you the units for your derivative.